Okay, so we've got this triangle here, and we can see it's called BCD. It's called the triangle A, and the vertices are B, C, and D. Triangle A is enlarged by a factor of 4.5. Draw the image with the point B at -8, 5. So -8, 5, and of course this is an image point, so it shouldn't be B, it should be B dashed. Now, this side here is of length 2 in the original triangle. So if you do 2 times 4.5, you'll find it's 9. So we've got to go down 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got to go down to here to put C dashed on the diagram. This is 3. 3 times 4.5, well, 3 times 4 is 12. 3 times 0.5 is 1.5, so that's 13.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.5. So that would be where D dashed is. Now I'm just going to try and draw this with the straight line tool so that we get a good result. So you should be using a ruler for this, obviously. Okay, so there's my triangle. Okay, so we've done that bit. Find the following information regarding the image. We want the area of the triangle. Well, obviously you've got the dimensions, you could work it out, but let's try doing it using scale factors. So we know the scale factor, the linear scale factor is 4.5, and that means the area scale factor is going to be 4.5 squared. So the original triangle is base times height divided by 2, which is 3. So the area of that triangle is going to be 3 times 4.5 squared. Obviously, as I said, you could actually work out the lengths and just do it that way. So I'm going to do 3 multiplied by 4.5 squared. That's going to give me 60.75. And that would be in meters squared. Length of the longest side. Okay, so the longest side is this one. So I think we're going to have to use Pythagoras here. So up here, BD, you should actually work in the space below, but I want to be able to see the diagram. BD is the square root of 3 squared plus 2 squared, which is the square root of 9 plus 4, which is root 13. So length of the longest side is going to be the scale factor times root 13. And we'll calculate that as well. Something we're going to have to round. 16.2, say 16.2 meters, correct to 1 decimal place. And the equation of the line BD. Now I think it was B dash D dash actually that was what actually required. Don't worry, that will become clear on your test. So, well, the gradient of that obviously is going to be the same as the gradient of this. So it's 3 across and 2 down. So the gradient is negative 2/3. So 2 down is negative. And so it's y equals negative 2/3 x plus a constant. It's not really very clear from this diagram exactly where this cuts. And we can't guesstimate that, so we're actually going to have to use some values to work this out. So we know the B there is the point to use because that was the one we were actually given, goes through negative 8, 5. So 5 is going to be negative 2 over 3 times negative 8 plus C. So 5 is going to be 16 over 3 plus C. 5 is going to be 5 1/3 plus c, means that c is equal to negative 1/3. 5 1/3 take away a third is 5. So y is going to be negative 2/3 x, take away 1/3